Hello, everybody. Today we are going to be covering lessons 1.6 and 1.7. Please make sure that you are completing the OMHS material as well. That is good material that also gives you some good places to practice. So don't forget to do that in addition to this video. All right, so let's talk about the triangle proportionality theorem. Okay. I don't really care that you know the title of the theorems. I just care that you know what they say. So if a line is parallel to one side of a triangle and intersects the other two sides, then it's dividing the sides into segments of proportional lengths. Okay, so in symbols, or in an if-then statement anyway, if you've got these parallel lines here, so if DE is parallel to AC, then these sides are going to be broken up proportionally. So I can say that BD over DA will equal BE over EC. The converse of that says if the sides are broken up proportionally, so if BD over DA is equal to BE over EC, then the lines will be parallel, DE and AC. Okay. So let's look at that in some examples. Okay, so I know that I have some parallel sides here, and I know that because of these arrows. And so what that means is these sides are being broken up proportionally. So I can say that 14 over 12 is equal to x over 15. Now you could have said 12 over 14 equals 15 over x, and that would be fine also. Once we know how the proportions are, then we can solve them with cross multiplication. So 12 times x is 12x, and 14 times 15. So 12x equals 210, and divide both sides by 12 to get x. And in this case, x is not a super pretty number. I'm just going to leave it 17.5. I'm going to jump down here to example 3. Example 3, we have some parallels, a parallel line in my triangle, and I know that's going to be breaking these sides up proportionally. So I can say x over 36 equals, but now I don't know this length right here. I know the whole thing is 55, and this piece is 45. So to find this piece, I can subtract and say, oh, it's 10, because 10 plus 45 equals 55. So x over 36 equals 10 over 45. And then we'll use our cross multiplying to solve for x. Oops. Divide both sides by 45, and x equals 8. Okay. Some students like to think of this parallel line as like a fraction bar, if it were to continue out, x over 36, 10 over 45, or if a fraction bar was here, say 14 over 12 and x over 15. If that helps you visualize it, it's fine. You're definitely allowed to use it. If it doesn't, then it doesn't, and you can set it up how we just learned. I would like you to try numbers 2 and number 4. Set up your proportion, cross multiply, and solve for x. Try that now. Okay, so for the second example, you should have x equals 48. It's possible that you set up your proportions slightly different than mine. Maybe you put 18 over x equals 21 over 56. That's fine. It's okay if we set it up differently, but when we cross multiply, we will have the same step. And then for number 4, you should have gotten x equals 24. Again, if you set this up slightly differently than mine, but when you cross multiplied, you still got 6x equals 147, then you still set it up correctly. Okay, now this works even if it's not a triangle, but you still have parallel lines. So if you have 3 or more parallel lines and they are being cut by transversals, those transversals are being cut proportionally. So in this example, I can say that 45 over 18 will equal 52 over x. And then cross multiply. 45x equals 52 times 18, which is 936. Divide both sides by 45, we get 20.8. Okay. Again, I'm going to jump down here to number 12. I have some parallel lines cut by 2 transversals. Those transversals will be cut proportionally. So I can say that 27 over x will equal 18 over, I don't know this piece, but I know this whole thing is 32. So if I do 32 minus 18, I get 14. So this piece is 14. And then we can cross multiply. So x times 18, 27 times 14, divide by 18, 21. Okay. Try number 11 and try number 13. Try that now. Okay, so for number 11, you should have gotten x equals 35. And for number 13, you should get 72. You can go ahead and check your work with mine in case you don't have those. So if you need to pause the video, please go ahead and pause it and check your work. If you don't understand a mistake that you made, put a star next to it to make a note to ask during office hours. We're also going to talk about the triangle angle bisector theorem. Again, I don't care that you know the title. I care that you know what it says. And it says that an angle bisector in a triangle separates the opposite sides into 2 segments that are proportional to the lengths of the other 2 sides of a triangle. So in this case, I have an angle bisector, and I know it's an angle bisector because it's cutting angle B into 2 equal parts. If that happens, then I can say the length of AD over the length of DC is equal to the length of AB over the length of BC. And there's some other ways that you can write this. This is just one of the ways that you can write this. So for example, it says if KM represents an angle bisector. It's actually very important for our problem because without knowing that this is an angle bisector, we wouldn't be able to set this up. But now I can say, okay, well, this angle bisector is cutting JL into proportional pieces. So I can say that 4.8 over x equals, and since it's cutting this side into proportional pieces, it's forcing these sides to also be proportional, 12 over 18. And now we can cross multiply. 12x equals 18 times 4.5, 86.4. Notice I did not round that, I left it as a 0.4. Divide by 12, x is 7.2. That idea will hold true for number 7. Let's look at number 8. If KM is an angle bisector, so these 2 pieces are congruent, then it's going to be cutting this side proportionally. So we need to find the length of ML. JL is 39. So if I subtract 15 from that, that'll tell me the length of ML. So ML is 24. And now I can set up my proportion. 15 over 24 will equal x over 36. Cross multiply, 24x equals 15 times 36, which is 540. Divide both sides by 24, 22.5. And I'm going to jump down here to number 10. Okay. In number 10, I have some expressions, but the idea is going to be the same. This is my angle bisector. It is cutting JL proportionally. JL is 45, JM is 27. So when I subtract, it'll tell me the length of ML. So ML is 18. Now I can set up my proportion. 27 over 18 will equal 3x minus 9 over x plus 11. Remember, anytime that we see an expression in our proportion, put parentheses around it right away, so that way you don't forget to distribute in the next step. Cross multiply. 18 times 3x minus 9 equals 27 times x plus 11. And now we'll distribute to both parts in the parentheses, which is why we needed those parentheses. 54x minus 162 equals 27x plus 297. And now we're going to solve for x. I'm going to subtract 27x from both sides. So I get 27x minus 162 equals 297. I'll add 162 to both sides. So I get 27x equals 459. Divide by 27, 17. Okay, so that's how we would do it if we saw expressions. It's the same process, just a few extra algebra steps, but nothing too terribly difficult. Some students, again, they like to think of that angle bisector as their fraction bar. Like if this was a fraction bar, 4.8 over x, or if this was your fraction bar, 15 over 24. If that's helpful for you to visualize it, please go ahead and use that. I'd like you to try this on number 7 and number 9. Do that now. Okay, so at number 7, you should have 48.6. I'd like to try number 9 with you. I'm hoping that when you looked at this, you were like, oh my goodness, x is the whole thing. How can I find ML? Well, just like over here in number 8, we take the length of the whole segment and subtract the piece that we know. So since the length of the whole thing is x and the piece that I know is 12, an expression to represent ML will be x minus 12. Okay. The length of the whole thing was x. The piece that we know is 12. So the piece that's left over will have to be the length of the whole thing minus the piece that we know. And once you know that expression, then you can go ahead and set up your proportion. 12 over x minus 12 will equal 18 over 30. Put the x minus 12 in parentheses and cross multiply. Hopefully at this point you know the rest of the steps, but I'm going to do them with you anyway. 360. Distribute the 18. 18 times 12 is 216. Add 216 to both sides. 576. Divide by 18, 32. If you did not set this up this way and you tried to plug this number in to an incorrect proportion, it would not have been equal. So that's a way to check. You can always take your x value and plug it back into your original proportion and make sure that those fractions actually are equal. Okay, so that is the triangle proportionality theorem. This is covered in 1.6 and 1.7 on OMHS. This was just a taste of those things. So please make sure that you are doing the content and not just relying on just this video. The attendance word for today is splitter. Today we practice triangle proportions with the side splitter method and angle bisectors. Your attendance word today is splitter. Make sure you spell it right on the attendance quiz. Have a wonderful day, everybody. If you need help, please don't hesitate to reach out for help during office hours, sign up for small group, or email. There's lots of places to get extra help. Have a great day.